Your organization is grappling with a data engineering dilemma. Vital information is buried in fragmented, inconsistent data sets scattered across multiple sources. The stakes are high, as these hidden data issues are blocking the path to strategic business decisions and operational insights. As the lead detective, your mission is to unravel the chaos, ingest, clean, transform, and analyze this tangled data landscape to reveal actionable intelligence. With Microsoft Fabric as your investigation headquarters and Copilot as your trusted assistant, you seamlessly orchestrate each stage of the data engineering workflow and close the case quickly. Welcome, detectives. My name's Jason Richards, Microsoft Technical Trainer and Data Detective. From consolidating disparate data streams in Data Factory to refining and structuring data in data engineering and conducting deep analysis in notebooks, you use Copilot as your assistant to swiftly translate your business questions into technical steps, ensuring every transformation brings you closer to solving a case and empowering your organization with reliable, business-ready insights. Ready to unlock the clues? Let's get started. We'll explore how Copilot streamlines every stage of the data engineering workflow in Microsoft Fabric. You'll see how Copilot enhances Dataflow Gen 2 by generating, cleaning, and transforming data using plain language instructions. How it accelerates data pipeline development through automated activity creation, troubleshooting, and summarization, and how it boosts productivity in Fabric notebooks, where it can generate code, answer questions, and guide analysis directly from your prompts. By the end, you'll understand how Copilot helps you move from raw data to refined insights faster, with less friction, and with AI working alongside you at every step. When working with Dataflow Gen 2, you use a visual, low-code interface to ingest and shape data, while your sidekick Copilot accelerates the process by converting natural language into transformation steps. As a detective, you're looking for structure and consistency, prompting Copilot to apply data types, add derived columns, filter records, or merge fields, then validating whether the outcome matches the investigative goal of cleaner, analysis-ready data. The transformation workflow follows a repeatable pattern: prompt, output, validation, and refinement. You start by supplying data, often through sample data generation. Then, guide Copilot to apply transformations one step at a time. Each refinement sharpens your ability to write precise prompts, helping you recognize how small wording changes can surface very different results, much like following or dismissing a misleading clue. Understanding the generated M code is part of skill building rather than a side effect. Copilot explains mashup code so you can connect intent to implementation, reinforcing how natural language instructions map to query logic. Over time, this builds confidence and gives you a gradual on-ramp to writing or reading M directly when deep customization is needed. Best practices with Dataflow Gen 2 focus on clarity and iteration. You get better results by limiting scope to data integration tasks, naming tables and columns explicitly, and validating each step before adding more complexity. Treat Copilot as an assistant that proposes approaches while you remain responsible for accuracy, sequencing, and business relevance. That wraps up our first case of Dataflow Gen 2 dilemmas. Now let's open the case of the pipeline pursuit and observe how Copilot can assist with orchestration. In Fabric data pipelines, Copilot helps scaffold ingestion and orchestration logic, but you still define the architectural intent. As a detective, you first ensure the basics exist: a workspace, a lakehouse, and valid connections. Because these establish the source to target trail Copilot will follow when generating pipeline activities. Connections define where data comes from and how it's accessed. You manage them centrally and reuse them across pipelines, ensuring governance and consistency. Copilot depends on these connections to propose copy activities, but you're responsible for choosing authentication types, validating access, and confirming that connection details align with organizational standards. When ingesting data, Copilot generates a copy data activity based on your prompt, but important details remain yours to supply. You select source and destination connections, target table names, file paths, formats, and delimiters. This shared responsibility reinforces that automation accelerates setup, but correctness still depends on human review. Pipelines may also include transformation or cleanup steps, and Copilot can insert additional activities using natural language. For example, it can add a delete operation to demonstrate pipeline orchestration flow. You then complete the configuration, maintaining control over the precision, data ownership, and governance boundaries. Essentially, Copilot sets you up and you uncover the details. Copilot can even summarize an entire pipeline in plain language, helping you quickly verify intent, understand flow, and explain the design to others. This summary acts as a consistency check, letting you confirm that ingestion, transformation, and orchestration align with the investigative outcome you intended. Orchestration acceleration solved. Now, how can our Copilot companion assist with the complexities of code generation? Let's take a look at the clues. In Fabric notebooks, Copilot assists with writing Spark code that works directly with Lakehouse data. You use it to generate code for loading data, transforming data frames, and saving results, while remaining responsible for verifying logic, performance, and data integrity in a distributed environment. Magic commands and the Copilot chat panel provide two entry points for this interaction. You use magic commands for structured tasks inside cells and chat for broader assistance. Providing concrete references such as file paths, table names, or data frame variables gives Copilot better context and dramatically improves output quality. In addition to magic commands, the Copilot chat panel acts as an interactive assistant that understands the full context of your notebook, allowing you to ask questions in plain language and receive actionable guidance. You can request code generation, ask for explanations of existing logic, troubleshoot data issues, or explore transformation strategies, all without needing to rewrite every step manually. This conversational approach streamlines complex data engineering tasks by turning intent into ready-to-run notebook cells. Using these chat capabilities, Copilot produces complete code snippets, generates full data ingestion workflows, cleans and reshapes data sets, and even recommends best practice structures for tables and pipelines. It can create reusable code fragments, assemble end-to-end workflows such as downloading files, loading them into a lakehouse and transforming them, and deliver clear explanations alongside the output. The result is faster development, consistent code quality, and simplified documentation across your Fabric notebook environment. Now that we gathered the clues on how to work with Copilot in data engineering workflows, let's put it into action. Now let's see. I have myself, I have my trusty assistant Copilot. Now all I need is the tool. And that, my friends, would be the trusty and a little dusty Detectolab 5000. Let's dive in and solve the mystery. As Contoso Health continues to expand, leadership has a suspicion that patient satisfaction may be quietly influencing readmission risk in several clinics. The challenge is that the evidence is scattered across systems, inconsistent in quality, and difficult to interpret in isolation. Welcome to the case of the satisfaction signal. To solve this case, we'll be using a medallion architecture in Microsoft Fabric. Our bronze layer will hold the raw evidence, silver will contain the verified and structured facts, and gold will represent the final insights ready for reporting and analytics. To speed things up, I've already created a workspace named Contoso Health and created a lakehouse named Contoso Medallion. This lakehouse will serve as the central repository for the entire investigation, storing the raw files, clean data sets, and curated tables in a single governed location. To clean and curate the data, we'll use several Copilot-enabled tools. A dataflow Gen 2 will handle silver level transformations. A notebook will perform gold layer aggregations. And a fabric pipeline will orchestrate everything end to end. With the help of Copilot, we'll create this end-to-end workflow and automate it without any programming language. Now, to speed things up, the silver folder has already been created. Also, the prompts I'll introduce have been pre-developed to speed things up. In your experience, make sure to validate at every step to ensure accuracy. Let's get started. Now, due to privacy concerns, we're asked to create synthetic data mirroring the objects of the data collected. Fortunately, Copilot inside Dataflow Gen 2 allows us to create patient satisfaction survey records. All right, so now I have my data flow up. Open up Copilot. And you can see that we're going to create a new query with 1,000 patient satisfaction records and being very detailed with the column names, what we want specifically from it. At this point, the data is intentionally raw. All values arrive as text, no assumptions are made, and no interpretations are applied. This is bronze data, preserved exactly as it's collected, because a good investigation always starts by respecting the original evidence. Once the raw data arrives, we'll move it into verification. But before applying any logic, we'll correct the data types so numeric values are numeric, dates are dates, and text remains text. This small step prevents subtle errors later and keeps downstream analysis focused on insights rather than cleanup. Next, we'll introduce a monthly time grain. Every piece of evidence needs a time bucket. And by adding a visit month column, we ensure that trends can be analyzed consistently at a clinic by month level. Then we'll push key business logic into the silver layer. We'll flag low satisfaction scores directly in the data flow instead of deferring that logic to the notebook. This design choice will simplify the gold layer, and it makes the intent of the data immediately clear. We'll also make record counts explicit by adding a column that represents a single survey response. Counts are data too, and by making them visible, aggregations become simpler, clearer, and easier to teach. To ensure consistent grouping, we'll normalize clinic identifiers so there's exactly one reliable key for aggregation. We'll also enrich the data with age ranges, which allows for more flexible slicing later without adding complexity to the gold logic. Before finalizing the silver layer, apply basic quality filters. Unrealistic ages and invalid satisfaction scores are going to be removed so the data set reflects plausible real-world behavior. At this point, we ask Copilot to explain the transformations back to us. This is a deliberate step. Copilot isn't just generating logic here, it's helping verify and trust that the work's been done. Once satisfied, we write the clean data results to the silver folder in the lakehouse. See the explanation here? Creating the destination target. Selecting the proper file location in the Silver folder, setting the file to save as a CSV named Patient Satisfaction Clean, validating the schema, and then we'll save it and run it. The Silver dataset is intentionally designed so that every column supports an aggregation, a filter, or a slice. There's no gold logic leaking backward and nothing left to interpret later. This is what a typical medallion architecture should look like. With the verified facts in place, we're ready to summarize the case. Let's open up a notebook from the Lakehouse to add it as the default resource. Before we start, we want to determine how magic commands will output, so we'll do that and ensure we have a connected Spark pool. All right, so you can see the default code generation output is set to next, and the default chat generation output is set to output. Next, we want to establish context with Copilot Chat, clearly stating which lakehouse I'm working in, where the Silver data lives, and what gold table I intend to produce. This sets expectations for Copilot. This is optional, but it does demonstrate that chat responses show up in the output of the cell. And you can see the output, so it's telling us where to load the data from, analyzing the columns, aggregating it, and then when we're going to write it. So it's just providing a description for what we're going to be doing. Now we'll ask Copilot to generate PySpark code to load the Silver data into a data frame. You'll notice the response shows up in a separate cell. Before running the cell, pause to review the code. AI-generated code accelerates work, but it never replaces judgment. All right, that looks good. That looks good. And we have an output, which is great. All right. After loading the data, we'll perform a quick profile to inspect the schema and the summary statistics. All right, so you can see the schema and the summary statistics that are in here. Now, if any date fields didn't infer correctly from the CSV, we can fix them explicitly so the data behaves exactly as we want it to. Code looks good. Date looks good. All right. Now the real payoff has begun. We'll ask Copilot to generate concise aggregation logic that groups the data by clinic and month, computes satisfaction metrics, calculates risk indicators, and produces a clean gold data frame. Because the investigative work has already been done in the silver layer, this entire aggregation fits comfortably on a single screen. Generated code, average sum, adding the at risk, creating the gold data frame from that. And the result. All right. All right, to reinforce understanding, we'll ask Copilot to annotate the code with short, clear comments explaining why each step exists. So you can see the output now, still the same code as before. Now it's added all these comments in here to explain exactly what's going on. All right, and now that we've reviewed that, we'll persist the results as a delta table in the lakehouse named Clinic KPI. All right, looks good. Writing takes a little time. All right. Now, just to confirm that we have our table, we'll go ahead and refresh the lakehouse. All right, looks like the table's been read in. And to query the table directly, we'll ask Copilot to generate equivalent logic in Spark SQL. This confirms that the data is registered, reusable, and ready for dashboards or downstream analytics. Now, since the default language in the notebook is PySpark, we need to update the cell with a magic command to change the language to SQL. Awesome, we have curated table for analysis. This is what Contoso wants when they plug in their data. To highlight some additional commands in a Fabric notebook, we can show chat history and clear it too. And there's our chat history. And then we can clear it. And with all the assets prepared, it's time to automate the investigation. Before we start, an additional tip. In your notebook, you'll want to clear the chat history, remove instructional cells like the code and chat magic operators, and leave only production-ready logic behind. Clean notebooks are easier to maintain, prevent unnecessary code execution, and easier to trust. For time's sake, this has already been applied. Now we can start building our pipeline. So we've created a Fabric pipeline called Contoso Pipeline. This pipeline will represent the entire case from start to finish. It'll clear old evidence, retransform data, recompute insights, and will notify us if anything goes wrong. We'll start the pipeline by asking Copilot to delete the existing Silver file so each run starts clean and ready for updated data. All right, our delete activity is created, but note that while Copilot creates activities, it won't fill in the blanks. We'll enter that information ourselves as we move through each one. Here, we just need to define the target file. I don't know if it's that. Okay, looks like our settings are set. So next we want to execute the dataflow gen 2 to rebuild the Silver layer again. Now we'll ask Copilot to generate the activity, and again, we'll fill in the blanks. Also notice in the logic in the prompt, we added that the activity should be run after the delete activity completes and succeeds. And this generates the integration between steps for us based on the state of the previous step. All right. After that's completed, we want the pipeline to run the gold aggregation notebook. Again, we'll ask Copilot to add the activity, and then we'll build the dependency chain. All right, everything looks good there. All right. So it will be also nice to be notified if the pipeline happens to fail. Let's ask Copilot to add an email notification that triggers if either the data flow or the notebook fails. If something breaks, we'll know immediately. Now notice that because of the details of the prompt that we created, Copilot recognized both activities that we already created and the correct dependency to the fail state of the activities. That's time saved, detectives. You can also see that we can add variables into the body of the message where I can just reference already created assets in the pipeline. All right. Finally, I'll ask Copilot to summarize the pipeline in plain language. This transforms technical configuration into a clean narrative that anyone can understand. And there you see the response. So it just describes what's happening, cleaning up through a delete activity, data transformation through the data flow, aggregation through the notebook, and then finally a failure notification for us if either the data flow or the notebook fail. Very nice. Now, we'll run the pipeline and monitor the execution. With a little time and maybe a little luck, the pipeline will complete successfully, confirming that the investigation works end to end. In a real production system, this pipeline could run on a schedule or respond to events, but the pattern remains the same. As you can see in this, it's verifying that every step in the process is succeeding, going through each step in the pipeline. There you have it, detectives. Copilot doesn't replace engineering judgment, it accelerates it. We still decide what runs, when it runs, and why it matters. Copilot just makes it easier to leverage several tools to accelerate the engineering process. Looks like the case of the satisfaction signal is a wrap. Let's head on back. As we wrap up this investigation, you've seen how Copilot and Microsoft Fabric becomes your trusted partner in solving analytics mysteries. From shaping raw clues into Dataflow Gen 2, to orchestrating airtight alibis with data pipelines, and finally cracking the case wide open in Fabric notebooks. The real win isn't that Copilot does the work for you, it's that it helps you think faster, test hypotheses sooner, and translate intent into action without losing sight of the fundamentals. You remain the lead detective, accountable for accuracy, governance, and insight, while Copilot speeds up the legwork, explains the evidence, and keeps the investigation moving forward. Used thoughtfully, it turns complex data engineering workflows into a clear narrative, from messy inputs to trustworthy outcomes, so you can spend less time wrestling tools and more time delivering answers. Thanks for joining.